we're going to get into more of different kinds of relationships. The examples that we've had so far have either been of a single table, where, of course, there can't be a relationship if there's only one table, or we have used a couple tables in one example, the movie and actor example, but we didn't do anything to relate those together. So what we're going to talk now is we're going to talk about relationships between two tables in a database. We'll talk some theory, talk about theory of relational databases relating to creating relationships between entities, the kinds of relationships there are, how they are implemented, and then we'll talk about how within the entity framework core of ASP.NET we implement those relationships. Simply put, there's three sorts of relationships within a database. There's a one-to-one relationship. Oh, I drew a many-to-many. It's a one-to-one relationship. These are actually pretty rare. Usually you'll find that relationships are one-to-many or many-to-many. One example of a one-to-one relationship is what is called an entity subtype. That is where you have an entity and certain members of that entity have some additional information, but not all of them. For example, there might be a table in our database, in a college's database for student. And there might be a separate table for international student. Everyone gets put in the student table, but only international students get put here too. So for example, with international students, there are restrictions as far as the kind of visa that they have and in numbers and dates and that sort of thing. So that kind of information, type of visa, number, the country they came from, and so on would be in the international student table. And it would be keyed by the same primary key, student ID. And that would have, for everyone, including international students, the student name, the student ID, the student name, address, email, and so on. In other words, everyone gets put in the main table, only international students get put in there. So a subtype of student, international student, has a table for just those fields that are distinct to that subtype. Why not just include these in here? Well, if we include these in here, we have to make them optional. And those fields should not be optional for international students. And if we put them in the regular student table, then for students that were not international students, they'd have blanks for these fields or nulls. And we wouldn't want an international student, however, to have nulls in there. So we build this relationship and make these required fields in this table. And if you're not an international student, you simply don't have a value in that second table. Another example for one-to-one relationship might be if you have between a division in the college, if you had a separate table for deans. Now, this might be handled a different way, but this is one way of implementing it where there would be a one-to-one relationship. If you had that, for example, a division has one dean and a dean is responsible for one division. What you do with that is you pick one of them and put the primary key of the other one as a foreign key to the other table. So you might put a dean ID in the division table. Alternatively, you could put a division ID in the dean's table. You would not do both though. You'd pick one. Whichever one you'd pick, you'd create a unique index to prevent there from being a dean that would be used twice in the division table. But these are rare. In fact, I would suggest that if you think you have a one-to-one relationship, think about it a little harder, and you might find that you have one of the other kinds of relationships. The other kind of relationship, one of the other kind, and the most common, is a one-to-many relationship. And this might be a relationship between an advisor and a student. Now, in determining this, the nature of the relationship, it's called the cardinality of the relationship, whether it's one-to-one, one-to-many, many-to-one. You have to look in both directions. In other words, one advisor can have many students. And you have to look the other way too. One student only has one advisor. If we have this, we have a one-to-many relationship. The way that you implement a one-to-many relationship is you put a foreign key in the many side. So you put a foreign key in the student table in this case that would point back to the advisor for that student. You can do that because one student only has one advisor. You could not do the opposite. I could not put a student ID in the advisor table because an advisor has multiple students. Which one of those students would we want to point to? We want to point to all of them, but we can't with just a single student ID number. And we're not going to have repeating fields, so we're not going to have multiple student IDs in the advisor table. So the many always points to the one. A foreign key guarantees that if you insert, no matter what you do, insert, update, delete, whatever, to the table, it guarantees that there has to be a match in the other table. So if there were advisors 1, 2, 3, if I tried to insert a student in the table, say student number 246, and I tried to insert them with number 4, it would not be allowed because there is no advisor number 4. That would violate what's called the referential integrity. So that makes sure, and it ensures on a database level, that you can't put bad data in there. You can't have data where a student has an advisor ID that is not a valid advisor. Now, depending on whether you leave it null or not, it's possible that the student may have no advisor. So I could put null in for the advisor, and if I had it set up that way, maybe you're not assigned an advisor right when you enroll as a student. So maybe you only are assigned an advisor when you reach a certain point of your career. I don't know what the rules are here at LC, but it might be possible to allow a null, in which case you would do that and you would not make that a required field. It works in the case of deletions as well. Let's say I have a student in here and I have a bunch of students with advisor number 3 in there. What happens when I try to delete advisor number 3? I can't leave these students out there hanging with a non-existent advisor. So one of two things has to happen. In most databases, one of two things happen. You either don't allow to delete from the parent table if there are any children, or you delete the children when you delete the parent. Now, in this case, it really wouldn't make sense to delete students just because the advisor resigned. All right? You wouldn't want that. So you would have restrict. It means that you could not delete the advisor until you transferred all these people to another advisor. Then, when there were no students for that advisor, then you could delete them. That's another thing you have to decide when you set up a foreign key. What are the rules when there is a deletion of the parent? Doesn't work the other way. In other words, if I delete student 246, I don't have to do anything with the advisors because the referential integrity is still enforced. There's just one less student that advisor number 1 advises. The last thing that we will deal with, and you do deal with these often, so you deal with one-to-many and many-to-many often. Don't deal with one-to-one so real often, but a many-to-many. And here's where you have to be very careful because you need to look in both directions. Let's say if we were looking at student and major. You really have to do your research and find out what the requirements and what the rules of the college are. Most colleges, for example, allow a student to have multiple majors. So you might think that one student has one major and a given major has multiple students, so you might think it's a one-to-many relationship. However, that may be the case in most instances, but you're not building a database that only works some of the time. You want to build a database that can handle all of the data within a system. And therefore, when you did further investigation, ask, gee, can a student have multiple majors? And many times, the answer will be yes, and there'll be a many-to-many relationship. Now, we can't put a student ID over in major because a major has more than one student. So we can't put one of the student's IDs as an attribute in the major. Likewise, we can't put the major ID as an attribute of the student. So instead, what we create, and this is how we resolve these many-to-manys in the database, is you create what's called an intersecting entity. And oftentimes it gets the name of the combination of the tables. Student major table. And it can have its own primary key of ID, and it will have as foreign keys a student ID and a major ID. Because this is the primary key, I can have duplicate student numbers in here with different majors. Or I could have the major in there with multiple students, and that's okay. Now, it's important that you understand that even though Entity Framework Core does a lot of the work for you simply by you creating the model correctly. All right. Remember, we're taking the approach of model first. We're developing our models, We define the entities, we define the attributes, and we update the database from what we have in the models. So we're doing a model first approach. We develop our model, make sure it's correct, and then create the database and update the database from the values that are in that model. Entity Framework Core is very clever at figuring out, gee, if there's a student ID, let's go back to an earlier example, simpler example. We have a student and advisor. It's smart enough to know if I have a column named ID, that that's the primary key. It's smart enough to know if I have an advisor ID in the student table, that that's probably a foreign key over to the advisor table. Now, there's ways through annotations that you can make that explicit if the entity framework core is not smart enough to figure it out. But it's usually able to figure things out, so we will create the model correctly. Okay, so we're going to look at this application, and we're going to probably spend a few weeks on this application. And there's a tutorial for this. We're not going to go over every detail in this application, but we're going to cover enough of it, hopefully, for you to be able to do your own assignment. Remember, by the way, if I'm not mistaken, your design is due this Wednesday. Check it out. Yes, it is. It's due tomorrow. So if you have not begun working on that, now would be a great time. Remember what you need to do. Strategy section, scope, structure, wireframe, prototype. Included in the scope is an ERD, entity relationship diagram, which you should be familiar from having CISS243. An entity relationship diagram is sort of what I was sketching in Paint. It shows the entities and the relationships between them, as well as any attributes in there. So we're going to go over that application today. And I have the code for it here that you can download and play along at home. I also have a resource about one-to-many relationships in ASP.NET Core Web API. I urge you to watch that. Along with this tutorial, and I would suggest get the Core 6 version. Along with this tutorial, that essentially is going to build the database for the application that we're looking at. So it would be great if you followed through that tutorial all the way through. If not, at least read through the tutorial. And here's more information. I think it's the same thing. I think I put the same link twice. Yeah, about this application. It shows you how important it is. I put it in twice. Okay, so let's open this application. We'll take a minute to run it to see some of the functionality. And our focus today is mainly going to be on the model. What do we do in the model to make these database relationships? So I downloaded it previously. And open it up. And when I run it, note if you download this, you need to first update the database. If you download any example, the first time that you download it, you need to update the database. I already did that earlier this morning, so I don't need to do it now. But if you were to download this now and play along at home, you would need to update the database too. Okay, this has several entities. This has students. When we click on a student, we see the courses that they are enrolled in. So there's a relationship between students and courses. Otherwise, we can edit student or delete a student. We have courses. We can edit. Here we could view the details of courses. Or we can delete it. We have instructors. The instructors come with a list of courses that they teach. If you select an instructor, it shows you all the courses they teach as a list down here. And if you select a course, it shows you the students that are enrolled in that course. If we do edit, we can assign courses to a teacher. I would suggest probably doing this another way because this seems very inefficient for LC, for example, where there are literally hundreds, if not thousands of courses. As I mentioned, some of the stuff we're not really going to go into in much detail. And finally, we have departments. And with departments, well, pretty boring. We just see the departments. One thing that's kind of neat is we have a drop down here for instructor. We can select and set from a drop down. So we'll be exploring this a little bit at a time, but today, purpose of today is to look at the model and to see how the model is created. So let's start out by looking at the models and student, instructor, department, and courses. There are two other models that don't correspond to things in the database. Oh, I'm sorry, enrollment does correspond to something in the database. Office assignment. There's a database table for that as well. So scratch that. These all correspond to database tables. I guess between office assignment and instructor would be a one-to-one relationship, the way that they had set it up. We could view the actual database if we want to by going to SQL Server Object Explorer, finding the database under local DB, databases, context, and here are the tables. Course instructor, departments, enrollment, instructor, office assignments, and student. So each one of these does compare. And we can look at, as we look at the model, we'll also take a quick look at the database to show how the model created these database tables. So let's start out with department. Okay, department has an ID, a department ID. And yes, is smart enough to figure out that a column named department ID is going to be the primary key. Simply based on the fact of what it is called. Public string name, budget, start date. Now this has an instructor ID. Why does it have an instructor ID? Because each department has an administrator, and that administrator is a instructor. If we're going to draw the ERD for this, we'd find this. Here's department. The department contains many instructors. And interestingly enough, the department has an administrator that's represented by a separate relationship. Sometimes it's useful on an ERD, especially if the relationships gets complicated, to put a quick description of what the relationship stands for. So this instructor ID relates to the administrator, because the instructor ID in the department, that means it points to one instructor, but a given instructor could have multiple departments that they're the administrator of, the way this database is set up. In addition to this instructor ID, we have an instructor object declared that we call administrator. So in this case, to implement that one-to-many relationship where an instructor is the administrator for this, we have both the instructor ID and we have this instructor that is called administrator. That tells us about this relationship. One-to-many for administrator. We look at the instructor. We have all their normal fields, ID, first name, middle name, last name. We have a computed column for full name, which simply concatenates the last name and the full I stand corrected. This relationship doesn't exist in this database. So there's only that administrator relationship. Because and I could tell that because if I look, I didn't see department listed as a member. Instructor, however, can teach a collection of courses. So the relationship between instructor and courses is that an instructor can teach multiple courses. Therefore, in the instructor, there's going to be a collection of courses. These things are going to get populated depending on how we write our queries. So we'll be able to loop through the list of courses for a given instructor if we want to. Finally, an instructor has an office assignment. Office assignment, again, simply consists of an instructor ID and the name of a location. The office assignment has an instructor, of course, the one that's pointed to by this instructor ID. Looking at the student, student has all the properties that it has. Plus it has a collection of enrollments. Now, what is the relationship between student and courses? One student can take many courses, so you might think, well, that's a one-to-many relationship. No, you have to go the reverse way too. One course can have many students. So what we're going to find here in the model is that student is going to have collection of enrollment records. An enrollment record matches up a student and a course ID and allows you to a place to put the grade as well. Each enrollment ID has both a student record and a course because each enrollment points to a student and a course. So we have the IDs of that student in the course, and we have a course and student object. We're not just going to have one or the other. Just because we have the student ID, we want to say, well, what is the student related to that enrollment record? Let's have a place to put that student object. So we define as an attribute of the enrollment object. Same thing with course. The enrollment object has a course ID and a spot to put the course information for that ID. In the course model, we specify that the course has a collection of enrollment and a collection of instructors. Actually, the way this is set up, a student or a course can teach, a course can be taught by multiple instructors. It has a department ID, and it has associated with that a department object. Let's summarize what we found, and let's start by looking at the student. A student has relationships with what? Has relationships with courses, but it's a many-to-many relationship, and therefore you need this intersecting entity called enrollments. So if we define this student object, we're going to define all the fields that the student has, plus we're going to say that they have a list of courses that they take. And that's exactly what we have here. We have all the list of all the fields, the ID, which gets turned into the primary key, the last name, the first name, middle initial, date of birth, or enrollment date rather, full name, which is a computed field. And then finally, we say that the student has a list of enrollments, because that's what a student has. We look at course, we'll see the same thing. That a course has all of its fields, then a list of enrollments, also a list of instructors, and a list of, or not a list of, but a single department. And this is the ID of that department. It's a little tricky to see this all at once. That's why I suggest you go through and at least read through the tutorial. Because the tutorial walks you through one step at a time. It shows you the ERD. Shows you the student entity. Along with this its notations. And then it creates a table. Read through this and check it out one step at a time to see sort of to get the full view of how these things are created. I said we were only going to look at the model today, but I do want to look at a little bit more. Let's look, for example, well, let's start by looking at the department. Details, the list, and so on. So let's start by looking off at that. That should be a nice, simple. We go under pages, departments. Remember, that should not be the same name as this. So if that's department, make this departments. And if we create our list, we'll notice that our list doesn't just contain information from the department table, it contains information from the faculty member that is the administrator. And when we either create a new or edit, we can change that via the drop down. So let's see how we accomplish that. Let's start by looking at the index for departments. Here we have a list of departments. Okay. This is very similar to what we had before. And our query is going to fill in that list of departments from the database. But then we have a new thing, include. What this include does is it includes any related data. So a department, as we saw, has a field called administrator, which is of type instructor. So in our model, we can say, I want to include for each department, I also want to include, I want to connect that department table to the appropriate administrator for that department. And I create the list. When I run this and create this, I have a list of departments, and that list contains all these fields associated with department, along with an instructor object that is that department's administrator. So that's all we had to do to join that to the instructor table and get the administrator. When we look at this, sort of looks like it did before. The only difference is when we say we want the item administrator, that's actually a complete instructor object. So we have to say what we want from the instructor object. And what do we want from the instructor object? Well, what are our choices? When we type in that, we get, do we want to see their first name, their hire date, their last name? We want to see a list of the courses they teach? No, we want their full name. So it knows a dot administrator for this item, for a department. It knows the administrator relates to an instructor, therefore it gives us a choice of those instructor fields. So that's why when we run this, we get these fields from the department table, the department entity. I'll probably use the term entity and table interchangeably, because it's really both of them. It's the model of the entity in the model class, and it also corresponds to the database table. Well, we get this from departments. We get this from the administrator, which is an instructor. So how do we do this? We can either look at edit or add. It's the same way. But how do we get the drop-down to work? Let's look at edit. First thing we're doing we have a department. All right, if we're editing a department, we have an instance of the department. We have a department object. We also have a select list. A select list is something that we're going to use to populate a drop-down. And that is comprised of a list of all of the instructors. So we want to pull into the department object all the fields from the department table, and we want to include the administrator. So we're loading up that administrator right off the bat. If we didn't find any, we return not found. We then do pull this select list from, creating a select list from the instructor table in the database, and we want the ID as the first field and the first middle name in the second field. So the select list is a collection that contains a value. This is what's going to be used in the dropdown, and the display text. So we're going to display the first name. The value, though, of each item in the dropdown is going to be the ID. So we do this by creating a select list. We create that select list by creating an instance of the select list class using the constructor and passing in what we want. We want from the list of all instructors, we want the ID and the first name. We then look at the razor page for this, and we simply say on the select ASP for department instructor ID. That's what ties this to the instructor ID in the department table. And we want the items of that list to come from that select list that we formed as part of the model. So we fill in that select list here. We then access it when we create the razor page and create the drop down. And this connects it so that the proper instructor ID will be displayed. And when we make a change to the instructor ID here, that will get put back into the department table. When we click submit, go through this long thing to see if anything has changed or whatever. We're not going to worry about this right today. But the bottom line is, trust me that in most cases, it's going to go and it's going to save the data back to the database. When we run this, let's look at the HTML that gets generated. I think that's always something useful to do with any server-side scripting, is look at the HTML that got generated. This dropdown is populated by Candace. All right. If we view the page source, we'll notice that here's the dropdown. It comes from that instructor list. The value of the option is the key. The display data is the first name. And we'll see that all the way down the line. Candace has a selected attribute, which means that she is the one that was assigned to that department initially. If we make that change to it, then when we submit it, that will be updated. But as of right now, she is the one that administers that department, so her row in the dropdown gets selected. All right, we'll be going over this. Parts of this are kind of complicated, and we might gloss over them. Other parts I do want to cover to show you how to do these queries and other functionality when multiple tables are involved. If there are no questions, that's all I had today. We'll see you next week. I will be in the WebEx room if you have any further questions after the meeting ends. If not, I will see you next week.